I'm David Youngman. I'm an application engineer at Allied Machine and Engineering, and today we're going to talk about a case study involving our VolCut product line. This is an application that was for an oil and gas component down in South America. Large diameter bore, 280 millimeter, which is just over 11 inches. It's quite a bit of a cost savings for the customer. And our field sales engineer, David Rainier, down in Brazil, is the one that ran this application and figured out the solution for it. And we'll bring him on to tell us a little more about the application.
Thank you, Dave, for having me. Good morning, everyone. This application was a bit of a challenge because when the customer called, he said, David, we're doing this in 3 shifts. It takes us over 25 hours to get one hole done. So when he called, we recently had come up with the VolCut product line, and we thought, wow, this might be a good solution for that.
And the VolCut, was that the first thing you thought of when you saw this large diameter bore and he presented you with the current method that they were using?
Yeah, the VolCut came in mind because the machine was a quite brand new machine. It's an HMC, horizontal machining center, and as a brand new machine, you have a lot of rigidity. On the other hand, you don't have that power that we need in the high torque for drilling such a large diameter hole. So we thought the VolCut, because it's a concept that works with high speed and low feed, and that goes easy on the machine as well.
And that's where our smaller IC inserts come into play with those type of machines that maybe don't have the torque and the thrust that are needed for the larger spade type inserts that you would see in some of the shops.
Exactly.
So,
yeah, and we were able to.
That would be a good option for that.
Mm-hmm. Yes, mainly because it does not require a lot of feed rate in order to achieve a good chip formation. So we were able to run it, and we got a very decent chip formation, and we were able to bore, to depth using those feeds and speeds. And this customer, the final diameter was 280 millimeters diameter, and the previous diameter was 200, just a bit, almost 8 inches diameter. So we decided to take that material in 2 passes to go easy on the machine, the tool itself, and also as our tool, the max depth of cut that we can take per pass on diameter is 76 millimeters around. So as we couldn't do that in one shot, we decided to do 2 passes. And another point that we were able to help the customer was to reduce the maintenance cost as well, because having a nice equipment like that, standing on the same position on a circulation movement, for almost 3 shifts in a row, it's kind of painful for the equipment. So our concept, it's like drilling a hole. You have only one movement feeding the tool, which is the Z movement, and X and Y is standing there at the same position the whole time. In the machine.
Yeah, and that's something else I guess they really need to look at too, is the additional benefits of some of our solutions that we have. And you bring up a good point about the machine maintenance. I mean, that's 25 hours of cut time. That's a long time for that machine to be running versus what we can provide with a standard product off the shelf.
And another thing that it's really great about this tool, using the same tool, the same setup, you can go anywhere from 200 to 280 millimeters diameter. You can adjust to whatever diameter you need, and you can, adjust the size for a finishing bore operation if you want to. So it's kind of
right, and that's a
point.
Yep. that's a huge benefit right there too, because we don't have a tool with a static diameter. We can adjust it. If we find out that we're not quite where we want to be on size, then we can adjust it, run it again, and we're there. So it's a good tool for the right application, and you definitely nailed it on this one.
Awesome. We did it together.
Yeah, that's right. That's right. We always work together. It's a good working relationship we have with our field sales engineers. A lot of them, like David, can, he does a lot on his own. He's very good at it, and as well as a lot of our other guys. But the application engineering department is here to help out our field sales engineers, and in a lot of cases we work hand in hand to find a solution for these applications.
Yeah, we're here to help. Just one call, away from you guys, or you can reach us by email or phone call. If you have any trouble with homemaking process, make sure you give us a chance. Let me know.
Yep, we're always here to help. You can contact the application engineering department at Allied Machine and Engineering at any time to discuss applications. We'd be more than happy to help.